So one of the big things that's been holding me back from 3D printing more car parts has been the design process. Everything that I have done with 3D prints and the parts that I have created so far, I have mostly done through FreeCAD, which, if you're unfamiliar, is a very simple shape-based 3D object editor. In order for me to create some more complex parts, I really need to learn a more complex CAD software. So lately I've been working on learning how to use FreeCAD, which, like FreeCAD, is another free program. However, unlike FreeCAD, it has much more complex and robust features for designing complex parts. FreeCAD did have the ability to adjust for size and dimension somewhat, but FreeCAD is set up much better to design parts based off dimensions and more accurate measurements at the beginning. So this time I am working on recreating a couple of pieces here. These are two of the 4 pads that go underneath the end caps of the roof rack for my S10 Blazer. If you saw the last video, I was recently working on refurbishing that roof rack to make the outside of the car look a whole heck of a lot better. And in the process, I decided to go ahead and design and 3D print some new pads to go along with the rest of that refurbishment. So make sure you go back and check out that video for the roof rack refurbishment if you're interested in that. And make sure you stay tuned until the end of this video to follow along on the more complex process of recreating these roof rack pads. Before I get too far into this too, I want to give a shout out to FreeCAD Academy here on YouTube. He's got a couple of videos that were a tremendous amount of help to me in learning how to use FreeCAD. So if you're interested in learning how to use the FreeCAD software, make sure you go check out his videos and give them a like, because he was, like I said, a great deal of help to me. So as part of my learning process off camera, I went ahead and started working on one of these pads. This is one of the rear pads. And after several iterations, I did finally come up with a design for this that is almost identical to the original part and works well on the car. So not sure how well you can see this on the camera, but here is one of the new rear pads that I created. Here is the rear end cap for the roof rack that it goes with, and it just fits there like that. There's nothing terribly special about these parts. They're basically just a gasket. But there you go, it fits. So to continue on with this process, since I've already created the rear one, I need to create the front pad. So follow along as I work on repeating the same process I used to create the rear one to create the front one. So the first thing we're going to want to do is go ahead and open up FreeCAD. Here is the rear pad that I designed. So you can see it's pretty complex as far as all these different measurements. Again, I'm very new to using FreeCAD, so this is probably horrible if you're familiar with this program and you are a seasoned 3D part designer or engineer. So I apologize for the mess that this is, but I did get it to work, and that was the most important part. So we'll go ahead and start. Close the sketch pad. All right, now we'll go ahead and start a new file. Going to name this one. This is when, oh, there we go. It's when you really start to feel like an idiot when you can't even rename the file that you just created. So roof rack pad front. And then I'm not going to try to teach you how to use FreeCAD because I barely know what I'm doing. So just kind of watch along. I'm going to create my sketch. This is where you design the basic outline, which is what you want to start with. So of course I need to start getting some measurements to create this design. So you definitely want to have a caliper and maybe a good tape measure or whatever other precision design tools. But we're going to need to take some measurements. So the first thing I want to do actually before I even start taking measurements is basically just create a rough outline of what this looks like. It doesn't have to be exact. So I'm going to start with the polyline tool, I think is what it's called. Seems to be the best thing for just kind of freehand recreating some of these shapes. So a straight line, it's pretty simple. Then we're going up on this part, so we need to have a big curve here. I have one curve, and then it's going to actually go into another curve, and then we're going to be back to a straight line, which is at an angle, but we'll fix that later. And then two more rounded corners on the bottom with a straight line in between. Okay. So there's a rough, very rough outline of the shape. So we'll go ahead and start setting some constraints here. Make that horizontal. Make both of those parallel. Well, that looks better already. So I think at this point we can go ahead and start with a measurement here. Zero out my caliper, and the first thing I'm going to start with is the width this way. Looks like about 46.5 millimeters. So I'm going to set the distance between these 2 points at 46.5. Okay. Things are getting a little screwed up there. Okay, let's make these equal to each other. Okay, now I could go and start making some of these holes and shapes on the inside, but we don't want to do that just yet because the outline is not complete. Now, you probably can't see this in the video, but the two radii for these corners are not the same. I've got them set to the same in the sketch right now, so I want to change them a little bit. This one on the left here looks pretty good. I don't have a compass or a great way to measure the radii on any of these curves, so I'm just kind of guessing and eyeballing it. You can get kind of a rough idea based off of the digital caliper here. Alright, so got a smaller radius on the left here and a bigger one on the right, which is how this part actually looks down here at the bottom. Doesn't mean that they're accurate, but so as you can see here, because these radii aren't equal, these points are not lining up exactly, so that distance, all of this is getting off a little bit. Actually, let's go back and just delete that. So I'm going to do it to line. And there we go. Now that distance is a little better. Okay, so I think that's pretty good on the width and those bottom radii. Now let's work on the top part here. This radius is much bigger than what it is on the part, so let's see what it's set to. Almost 11 millimeters. I'm going to say about 3. And again, this is not a very scientific way to design this stuff, but I never said I was an expert. Alright, I think that's pretty close for that one. This is the largest radius on this part at the top here. Okay, now I'm just being a little bit silly and kind of eyeballing it based off the screen here. I know, not a great way to do this, but again, I'm just trying to get something out. If I got to tweak it several times to get it perfect, so be it. Okay, so the next thing I need to do is measure the height, or the overall height of this part. Unfortunately, it is taller than my caliper is, so I'm going to max out the caliper, measure to a point, and then measure again, and then add them together. So 305 millimeters is the height, or at least that's what we're going to start with here. Set a distance there for that top point, 305. Alright, now it changes it. Okay, now we just have 1 degree of freedom left that we've got to adjust here. And then we're fully constrained in this model, and then I can go ahead and start working on the center sections. Alright, so all I did there was make this line tangent off of this radius. So now my thing is green. I'm fully constrained. So there's the basic outline of the part. Close this. There it is again. And then if you want to create the 3D object out of it, there it is. And there's a thinner version that's That's not the final thickness. I need to go back and double check what I used for the rear pieces so I make the thickness the same for these front pieces. But for now, we can go back and keep working on that sketch. Move all this stuff out as much as I can so it's not in my way. Okay, so what I did for the rear section is to just start here at the bottom and start creating the shapes inside of this. So there is a shape here that's not quite a rectangle because it's, well, all four corners are radius for one thing, and then there's another radius here in the middle of the top part. So I'm going to take measurements to get the rough size of this and then start putting it in there. So width is going to be the easiest. So 29.5 millimeters wide. So just like I created the outline, I'm going to go back in and use the polyline tool because I know I have straight and radius sections. So this is the, I believe, the easiest way to do it. 1, 2, 3. Straight line. 1, 2, 3. Try to get these as close to straight as you can. Just like we did with the outline, we'll fix that later. And there's the rough shape to start with. So then we'll start fixing it. Okay. Sometimes it does weird stuff. Don't ask me why, I just started using this. Alright, those are parallel because they're both vertical, so that's good. Make that one vertical. That looks a little better there. So the other thing that's a good place to keep going with this, once we've measured the width of it overall, actually I need to set that, what did I say it was? 29.5? 29.5 basically. So there's that. And then the next thing is going to be just measuring the edges here, what the thickness of all of these are, and that's going to be some good dimensions for you to put in there. So on the bottom, I'm going to say 10 millimeters. On the right side here, let's see. This one's a little narrower. This one's approximately 8 millimeters. 8 millimeters. Okay, now let's do the other side. That one's basically 10 as well. 10. Okay, 10 is good. Make these two bottom radii the same because I'm pretty sure they're the same. Doesn't really matter for this part. Okay, audio should be better now. Sorry about that. I apparently did not have the microphone turned on correctly. So here is our internal shape. I've got these two sides backwards. It should be higher on the left side than it is on the right side. So let's go ahead and work on fixing that now. So you can see as you change things based off the parameters you've already set, it changes the shape, and then you just have to keep adjusting. That's a little closer to the shape that we're going for. So that's pretty close right there. Again, these internal shapes, at least these cutouts, don't have to be perfectly exact because they're not meant to help with alignment or anything else. It's really, I believe, just to cut down on the material for these parts. If I really wanted to, I could make the whole center of this more or less full or filled in, with the exception of these little circular cutouts, because of course this is where the bolts come through and bolt to the roof of the car. So I'm going to go ahead and leave that alone for right now, and I'm going to start working on the circular cutout for the bolt. Great polyline tool again. So straight line, circle, straight line, circle. All right, now let's fix it. Okay. Make sure these are horizontal. All right, that's good. Double check here again. 52 millimeters roughly from the bottom of the slot here to the bottom of the part. So you can see based off that, that changes all of this. I can go back and make this a little smaller to give that more room. And then let's see, for the opening of the slot itself, about 14 millimeters, so we'll set that. And then let's set, I could set the width here, but what I actually want to do is set the distance from this side of the loop to the edge of the part, and then vice versa, and that's how I'm going to set those distances and dimensions there. So let's start with the one on the right. That's approximately 9.5 millimeters. Again, this is not the most precise way to do this, but these aren't really precision parts, so it's not going to be that big of a difference. 9.3 millimeters. And then let's do the same thing on the opposite side. I call that 22.5. Now apparently I've done something wrong here, because I should have more of a slot than a circle here. So apparently what I've done here is not make the overall part as wide as it needs to be. Yep, somehow I did not get the measurement correct for the overall width, so I should be able to go back in here and change that. There we go, made the whole part wider. So now the slot is elongated. I've got the distance here from the left side correct and the distance here from the right side correct. So that changed some of my other things down here. But I'm not too worried about that again. The main thing is the overall outline and where these slots are located. So I think that's good. Let's see, what else have I got here? Okay, so that point's not set properly. And sometimes you do things that it doesn't like, or at least I do, because like I said, I don't exactly know what I'm doing. I just have enough knowledge to be dangerous. So there again, it says it's a redundant constraint. It doesn't like that. Okay, well, I'm going to try something different here. Since that doesn't seem to be working, I'm going to try to set the distance or the width of the slot, since I can measure that. I call that 18 millimeters. And you can see there it was very close, 18.2, telling it to be 18, which should eliminate a degree of freedom here. Okay, here is the radius point for that curve down there, and here are these radius points. So I'm going to make these the same. That looks good. Still have 6 degrees of freedom. Okay, so I guess it wants me to set a height on that dot, which I should be able to do. Alright, this is going to be an estimate. Okay, that point's set. Alright, there's some more points gone, 4 degrees of freedom left. Again, I'm just kind of guessing on these radii here because they don't really matter that much. Just want to get close. 2 degrees of freedom left. We got this radius. 1 degree of freedom left. Okay, so I now need to set this point. Actually, I'll make these 2 points equal, and that should take care of it. We'll see. Nope, didn't do it. So my measurement here is 59. So let's do the same thing again. 59. Alright, fully constrained, everything's green, so that's what we're looking for. So that means we can move on to the next segment above. So I basically just need to create another shape like this one above this, and then as you can see on the original part, we're going to create this one, and then another one, and then another slot, and then 2 more openings. So I'm not going to bore you with every single last part of this step, so I'm going to get to work on creating these last couple of pieces in the middle there, and then I will check back. All right, first test print of the front pad. Again, I'm printing these very thin to try to save some plastic and some print time. So we'll let this go ahead and finish, then we'll come back, check it against the original part, and see how close I got it. Well, this test print ended up coming out okay. I wasn't terribly happy with the way that it fit, so I went back, made another change, and printed another one. And then I repeated that process several times. Ultimately, I did print quite a few test prints, and for the rear pad, the one that I started with, I ended up getting a finished product that I was relatively happy with, but it still wasn't completely perfect and an exact match to the original part. For these front pads that I have been showing you most of in this video, it ended up being off by even more, so I really wasn't happy with that. I ended up deciding to go ahead and put the roof rack back on the S10 Blazer with the original parts. So technically, I guess that's a failure to end this video. I didn't end up with a finished product that I was completely happy with, but it's not the end. I am going to come back and work on this a little bit more in the future to try to get these narrowed down, especially the front ones, to something that I'm happy with, not only to put on my car, but also to be able to sell in case anybody needs replacements for these. So to achieve that, I printed out some radius gauges, just another thing that I found on Thingiverse, and this is what I should have done in the first place, because this enables me to get a more accurate reading of each of the radiuses, or radii, technically, on these parts. So check back for part 2. I'm going to go back and revisit this and hopefully come up with something a little bit better. I hate to end a video on failure, but that's the way things go sometimes. So thank you very much for watching until the end if you have. Make sure you check back again for the second part of this video at some point in the future, and all the other content that I'm working on putting out. Click that thumbs up and like this video if you did. Subscribe to the channel if you haven't yet, and if you've got something to add, leave me a comment down below. I really appreciate all of that. So thank you again, and I will see you next time.